So when you log in, you're going to see this front page every time you log in. This first part, the algebra, lecture handouts, lecture handout videos, and so on, that'll always stay up there. What's going to change is the getting started and the week 1A link. This getting started will be up there for the first couple of days, and then it'll just say week 1A. Once we finish week 1A, then week 1B will be up there. And the weeks are split up in terms of weeks 1 through 8, and then first half is an A and the second half is a B. So you'll want to click on the getting started if you haven't already done so and watch the introduction video. It gives you a general overview of the way the course works. Then probably the most important link is this register in Mymathlab. And this is where it will give you the directions for registering in Mymathlab. You want to follow this to a T. The way that you register in Mymathlab is by clicking on My Lab and Mastering and going through the registration in there. If you do it straight from Pearson's website, it's going to ask you for a course ID. And that will be the ticket or your way of knowing you're doing it the wrong way. Give me 1 second. I have a student trying to get into the course. Okay. And so once you register in Mymathlab, that's when you're ready to go. That's when you can click on week 1A and you'll see all of the items that you need to complete for this week. I'd like to go over the syllabus with you that you'll find under the syllabus link. My office hours are Tuesday, Thursday, 10 to 11 a.m. in Boykin Hall 215 and 1:20 to 2:25 in Boykin Hall 215. Sorry, those have changed. It is just Tuesday, 10 to 11. All right. Also online by appointment. You guys are taking an online class, so I highly doubt you're going to show up in my face-to-face office, but I'll always be able to meet you online if we can come up with an agreed upon time. Email me and we could set something up. This course is taught 100% online. As I told you already, please watch the welcome video posted in Canvas before you get started. We work in Canvas and the textbook. The textbook that we work off is this Sullivan Elementary and Intermediate Algebra. However, you only need to purchase the Mymathlab access code and you'll have access to an ebook. So you can either purchase it in the bookstore or you can purchase it online somewhere for a lot cheaper. I've found it on eBay for as low as maybe $60. Amazon maybe around $80 or $90. I think the bookstore is well over $100. However, you can obtain a temporary access when you register for Mymathlab. Again, you're only required to purchase a Mymathlab student access code. Without an access code, you will not be able to access the course assessments and tutorials. Please watch the video posted in Canvas on how to register for Mymathlab. You will have the option of obtaining temporary access when you register for Mymathlab online. All right, so this course is structured with the lecture handouts. You'll see the link on the front page of Canvas. You'll find a lecture handout for each section covered in the course. These are great practice for you to prepare yourself for the exams. You will find YouTube videos posted in Canvas that go over these handouts. I will also go over these in the webinars, or some of these in the webinars. The webinars we're going to have on Mondays and Thursdays at 9 p.m. You'll access these in Canvas the same way you access this one. Problems from those lecture handouts will be posted in Canvas and they're covered in these webinars. The on-campus exams, there will be YouTube videos that cover the review for the exams, and you will take the on-campus exams in the LTLC building, as what we like to call it, the TLC building on the Valencia campus. You'll have a 3-day window of time to take your exams, Thursday, Friday, Saturday, and the average of your 3 exams is worth 50% of your class grade. The final exam is worth 20% of your class grade. I'll show you the schedule that's posted in Canvas that outlines the dates of the exams. Notice the hours for the Learning Center for taking your exams, Monday through Thursday, 8 a.m. to 8 p.m., Friday and Saturday, limited hours, 9 to 1. The exams are typically, you're given 2 hours and 25 minutes to take those exams. They don't typically take that long, but you want to make sure you show up and give yourself enough time. The online homework is given in Mymathlab. It's a great way to practice the material. The online homework will be accessed through Canvas. You can work on the assignments over and over again until you get 100%. You'll be expected to get 80% or better on these. And once you get 80% or better on these, then the online test becomes available. If you don't get 80% or better, the online test does not become available. Please try to work on these according to the dates in the schedule so that you have enough time to get 80%. These homeworks are going to be due on Thursday. Is that correct? The first homeworks are due 2.2, 2.3, 2.4 on Thursday, April 12th at midnight. You do not want to wait till Thursday at 8 p.m. to try to finish all 4 of these. You will not have enough time. So you want to work ahead. These have a deadline of 11:59 p.m. Thursdays and Sundays. The online homework is worth 15% of your class grade. Once you get that 80% or better, the online tests become available. You access these through Mymathlab. Through Canvas, the tests open up once you get 80% or better on all of the homework. They're timed and you'll have 3 attempts. Once you get started on a test, you'll be able to save it and come back if you need. You'll be expected to go in the order that the problems are presented, and you can't go back to previously viewed questions. Now, again, you will have 3 attempts on these. These are due on Friday and Mondays. Okay, so the homework is due Thursday. The test is then due Friday by midnight. The next set of homework is going to be due on Sunday, and the next day will be the test due on Monday. If you give yourself enough time, you should do very well on these, meaning if you get your homework done well before Thursday, you'll have plenty of time to take your 3 attempts on those online tests. These tests will not be available after the due date. The online tests are worth 15% of your class grade. So we went over the exams being 50%, the final 20%, online homework 15%, and online tests 15%. While taking exams, there will be no calculators or any electronic devices allowed. You'll be expected to store these in a locker according to the TLC rules. There'll be no bathroom breaks allowed while taking an exam. Any instance of cheating will be forwarded to the Dean of Student Services. These are the overarching goals of the course: to analyze and interpret equations of lines, solve and analyze systems of linear equations, and factor polynomials. All right, so that's all just the details, the rules of the course. So you're going to want to print out this course schedule and have this by you at all times. It's going to be a rather intense 8 weeks for you because it's a short-term course. So have this by you at all times. Keep a small picture of it in your wallet, your purse, something like that, so you can keep these dates by you at all times. So week 1A is from the 9th to the 12th or the 13th, as we say, because the test is due on the 13th. And week 1B is going to be from the 13th through the 16th, and so on. Our first exam is going to be on April 26th. You can take it on the 26th, 27th, and 28th in the TLC lab. You will find the exam reviews posted under this link, and there will be a YouTube video that goes over those exam reviews. You'll find the lecture handouts here, all of them. And for every one of those lecture handouts, you will find a YouTube video posted here. For example, Chapter 2, Chapter 2.2, and there they all are. I will post them under each respective week. This is where you're going to access your material. So week 1A, your online homework is 2-2 through 2-4 due Thursday, April 12th at 11:59 p.m. 80% or better on all those assignments in order to get online test 1 to open up. Online test 1 on 2-2 through 2-4 is due Friday, April 13th at 11:59 p.m. You have 3 tries to get your best score. Here's a link to the review homework. And if this link ever says that the homework is not available, off this link, then you can go ahead and click My Lab and Master it on the left-hand side and access it that way. Here's a link to the handout, which is opened right there in front of you. You can minimize the file preview if you want and make it smaller and make it look something like that. The video for section 2.2 that goes over that handout is the one in the pink. Once you're done with that, then you do your 2.2 homework. Then on to 2.3 handout, 2.3 video, 2.3 homework. Then on to 2.4 handout, video, homework. And then you should be ready for your online test 1. It's going to be due Friday, April 13th. Okay, so that is essentially how the course works. Not much more to it. Does anyone have any questions? You're welcome to use your microphone if you want, if you have any questions. And if you don't, I'm going to go ahead and lecture on talk about some of the beginning material. So again, just to reiterate, work on these homeworks a little bit each day. You know, for example, finish the review, the 2.2 by tomorrow, 2.3 by Tuesday, 2.4 by Wednesday. That way, you have all day Thursday to start the first test. Figure out what's on that test and take your second attempt. Then you know what you need to study more of to take your third attempt. If you get these homeworks done early, you're going to have plenty of time to do well in the online tests. I see it over and over again, people waiting to do these the last day, and I get a lot of emails on this first group of assignments saying to me, oh, I didn't get all my homework done at the 80% or better. Can I make it up because the test isn't opening up? And I say, no, you need to get on these early. All right. If you could just type in that chat that you say, you know, if you say, no, I don't have any questions or something like that, I'll know that you guys are still listening to me. Does anyone have any questions? Thank you, Michael. Thank you, Amy. All right. What usually happens is the good students are the ones who show up to my webinars, and I'm sure you guys have probably already read most of this material and know what's going on here. If you haven't already done so, please email me back and give me your cell phone number, because I'd like to use that to send text messages to you guys about the agenda for the week and give you guys reminders. I've learned in teaching online classes that it helps to hit you many different ways with reminders of what's due and what you should be working on. And some of you who are here tonight have already given me that cell phone number, so thank you.
Let's finish. Congratulations, you've officially registered. Now, let me show you how to access your course from Canvas.
Okay, so for the first handout, we're going to be covering the linear equations using the properties together. Now, this is going to go fairly quickly here because I'm going to try to give you an overview of the first 3 sections. But keep in mind that you can always go back to the lecture handout videos posted in Canvas, and you can see a much slower version of these handouts where you can actually pause it, rewind it, and look at it over again. So what I mean by using the properties together is example or practice 3a. This says that x plus 8 equals 5. The first property says that you can subtract 8 from both sides. And 5 minus 8 is negative 3. Letter B says if you're multiplying something by x, you can always divide both sides by that number, negative 3/4, and divide 36 by negative 3/4 and get x is equal to 36 divided by negative 3/4. So we divided by a number on both sides of the equation. Remember, when you divide fractions, you multiply by their reciprocals. And 3 goes into 3 one time and into 36 12 times. And that gives us 12 times negative 4 is negative 48. So those are the 2 properties. You have the addition property of equality, and you have the multiplication property of equality, or division if we want to look at it that way. And so that's what we have in example 1. The 2 properties together, addition and multiplication properties. You always apply the addition property first. So if you have a minus 9, you want to add 9 to both sides. (12 plus 9 is 21. It's the second step where you use the multiplication property. So you divide both sides by 3. So that's what we mean by using both properties together. Example 2, so we're adding 8 to the 2/3 x. And so we subtract 8 from both sides. Always undo the addition portion first. 8 minus 8, 0, and 12 minus 8 is 4. Now, what I just said in this last example is, the 2 examples ago, is if you're multiplying by 2/3, you can divide by 2/3. Cancels that, and you have x equals 4 divided by 2/3. But what you see in the end, what we're really doing is multiplying 4 by 3/2, which gives you 2 goes into 2 once and into 4 twice, which gives us 6. So what you'll see me doing from now on is, rather than divide by 2/3, I'll multiply by the reciprocal, because that cancels the coefficient of x, and then we're left with 2 goes into 4 twice. It gives us 6. So we like to say multiply by the reciprocal. Okay. Sometimes we have parentheses around 2 terms. In order to get rid of those parentheses, we distribute the 1/3 times the 2x and the 1/3 times the 9. 1/3 times 2 is 2/3. And then we have the x on that. And 1/3 times 9 is 3. And x over 3, that's also thought of as 1/3 x. On the left side, we have these two terms that are like each other. 2/3 x plus 1/3 x. When we have like terms, we add the numbers in front. 2/3 plus 1/3 is 3/3, or 1. And so if you put an x on those, you're just left with 1x. And remember, we like it to just say x. So we subtract 3 from both sides, and that says x is equal to 2. Now, if you have like terms, but they're on the different sides of the equation, since the 3x and the 5x are on different sides of the equation, I need them to all be on the same side. So I say, let's get rid of the 5x on the right-hand side. We can do that by subtracting 5x from both sides. If I subtract 5x from the right side, it gets rid of that 5x. If I subtract it from the left side, 3x minus 5x is negative 2x. Now we undo what we're adding or subtracting first. So we subtract the 4. And we get negative 2x. Negative 8 minus 4 is negative 12. Remember, when we use both properties together, we always first undo the addition portion. Step 2, now we undo the multiplication portion. So we divide both sides by negative 2. And we get x equals 6. We can always check these. Left side is 3 times 6 plus 4. The right side is 5 times 6 minus 8. This is 18 plus 12. Sorry, 18 plus 4, which is 22. And this is 30 minus 8, which is 22. So we like to proceduralize this and say things like, if you have any parentheses involved, that's step 1. Get rid of all those. If you have any like terms on the same side of the equation, combine those. Then is when we get all of the terms with the variable on the same side and the constants on the other side. The last step is always the multiplication property of equality to solve for x. And so that's like practice 5. Tell you what, I'll give you guys just a couple of minutes to attempt that one. 2 or 3 minutes. All right, anyone get close to an answer here? X equal 1. Well, I would check that one. I would say negative 10 minus 2 times 1 would be negative 12. And 1 times 2 is 2 minus 3 is negative 1 times 3 is negative 1. And 1 times negative 9 is negative 9. 1 times 2 is 2 minus 3 is negative 1 times 3. Yeah. That works. 9 plus negative 3 is negative 12. All right, so we got a little bit of everything here. We got parentheses. Negative 9x plus, we distribute. 3 times 2x is 6x. 3 times negative 3 is negative 9. Goes negative 10 minus 2x. We have variables on the same side, so those are combined because they're like terms. We get negative 3x.
And at the end of it, you're going to have to make a decision. Will you do?
Now we have variables on both sides of the equation, so we undo the negative 2x on the right by adding it. We add it to both sides. Cancels that. Negative 3 plus 2 is negative 1. Now we undo the addition or subtraction portion by adding 9. And negative 10 plus 9 is negative 1.
Unless he's setting you up.
Negative x is negative 1, so we divide negative 1 to get rid of the negatives. And we have x is equal to negative 1 over negative 1, which is positive 1.
Now.
All right, 2.3.
Know your rights.
This one deals with solving equations that have fractions in them.
Wouldn't you have to like make sure
So remember, the least common denominator is the smallest number.
That's one of them.
how can you prove that just by looking at it?
In here somewhere.
That is divisible by 5, 4.
But can't see what you're talking about. No way.
So it's kind of a big number because it has to be divisible by 5, 4, and 2. So numbers that are divisible by 5 are 5, 10, 15, 20, 25, 30, and so on. Numbers that are divisible by 4 are 4, 8, 12, 16, 24, 28, and so on. To be divisible by 2, 4, 6, 8, 10, 14, 16, 18, 20, 22, and so on. And when you look at the list, the 3 lists, you see that 20 is the smallest number common to all of those. The smallest number that is divisible by 5, 4, and 2 is 20. That's because if you take 20 and divide by 5, you get 4. 20 divided by 4 is 5, and 20 divided by 2 is 10. So we're going to use the multiplication property and multiply every one of these pieces by 20.
She got 11 months. I should be me. I should be doing that time. No, we went over this. It's good. How's it good? It's a minimum security place in Phoenix. And no, I'm not going to tell you which one. She'll get out of there and she'll be fine. You keep your promise and steer clear and she can have a good life. She can do what she's supposed to. And if I can't do that, then you gotta promise me that you will. I promise you. You should do something for me.
Negative those.
Bella's.
I was able to finish the lunches. Don't judge.
Sorry about that noise. I don't know who that was. I had my volume down, so that's why I couldn't hear it. So remember, we chose 20 because 20 divided by 5 is 4. 5 goes into 5 once, into 24, and then 4 times 2 is 8. 20 over 4 is 5. And 20 over 2 is 10. 10 times 3 is 30. And so then we have like terms on the left side. 8x minus 5x is 3x. We apply the multiplication property and divide both sides by 3. And that gives us x is equal to 10. Let's try one more of these. Our denominators this time are 6, 9, 3, and 18. 6, 12, 18, 24, 36. 9 goes times 2 is 18, times 3 is 27, times 4 is 36. 3 goes 3, 6, 9, 12, 15, 18, and there it is. 18 is the LCD. So take that 18 and multiply it by each piece. Now 6 goes into 18 3 times. We're left with 15x. And 9 goes into 18 2 times, and that leaves us with 4 then. 3 goes into 18 6 times. That's going to be negative 6x. And 18 over 18 is 1. That's going to leave us with minus 5. Now we have something a little easier to solve. We want to get rid of the negative 6x on the right side, so we add it. We add 6x. 15x plus 6x is 21x. Then we want to get rid of the plus 4, so we subtract it from both sides. Negative 5 minus 4 is negative 9. And we have 21x equals negative 9. So we divide by 21. And we have x is equal to negative 9 over 21, which when we divide both top and bottom by 3, we get negative 3/7. Okay, so clearing the fractions by multiplying by the LCD is an important topic. Now, if you have decimals, this is a lot easier to deal with because decimals are either denominators of 10, 100, 1,000, 10,000, 100,000, and so on. Because when you have 0.02, that's thought of as 2/100ths. So it's about the number of decimal spaces you have. If it's a 0.02, 2 decimal spaces, multiply everything by 100. 100 times 0.02 is 2. And 100 times 4 is 400. So what I do to the left side, I must also do to the right side. Then I divide both sides by 2, and I get x is equal to 200. Now, it's not super necessary to do that because you could have just divided both sides by 0.02 and then do long division 0.02 into 4, which means you have to move that over twice and 2 spaces to the right, and then get 2 into 400, which is 200. However, in example 5, it's a little easier to do this problem by clearing the decimal first. And you're going to start to see this equation, this type of equation, over and over again for the first couple of units. That stands for something that had a cost of C dollars that was reduced by 25%, and the sale price is $120. So again, remember the number of decimal spaces you see there tells you if you need 10 or 100 or 1,000 or 10,000 or 100,000 and so on. With 2 decimal spaces, we're going to use 100 and we're going to multiply both sides by 100. So I'm going to multiply the C by 100, the 0.25 C by 100, and the 120 by 100. I get 100C, and 100 times 0.25 is 25. Remember, when you multiply something by 100, it moves the decimal 2 spaces to the right. And then 100 times 120 is 2 spaces to the right, 12,000. Now it's a little easier to see. 100C minus 25C is 75C equals 12,000. Now we divide both sides by 75. And we have C equals 12,000 divided by 75. So we have to do a little long division, and 75 goes into 120 one time. The remainder 45, and 75 goes into 450. 6 times, and so we get 160. And so as we'll see later, this stands for $160 that was reduced by 25% of 160, which is $40, equals $120. So the original cost would have been $160.
I have a question.
Yeah, go ahead.
So when you say to multiply both sides by 100, is that because that's how many decimal points are in the decimal?
Exactly right. When you have a 0.25, that says you need to multiply by something with 2 zeros, like 100. Practice 3 says you have 1 decimal space and 2 decimal spaces. You pick the one that has the most. So we're going to multiply both sides of this one by 100.
Okay, thank you.
You're welcome. So we take 100 times P. 100 times 0.05 P. And 100 times 52.5. Hundred times P is 100P. And 100 times 0.05, 2 spaces to the right, makes it 5P. 100 times 52.5 is 2 spaces to the right, 5,250. And so that gives us 100p plus 5p, which is 105p. Equals 5250. Dividing both sides by 105, we have p equals 5,250 divided by 105. That gives us 105 into 525 goes 5 times. 5 times 5 is 25, and 5 times 1 is 5. Remainder 0, and 105 goes into 0. 0 times, which gives us 50. P equals 50. Okay, so example 5 represented something that cost $160 and reduced it by 25%, and the sale price is $120. Practice 3 stands for something that had a price of $50 and got increased by 5% and ended up being $52.50. Both of these are very important problems for this class. We'll see these again soon. Okay, the last idea here is there are some types of equations that you're going to be given that either just can't work at all or work for all real numbers. The types of equations that we were just working with, where we got a solution like x equals 2, this is true under the condition that x is 2. So that's called a conditional equation, one that is true for some values of the variable and false for others. But what you'll see in this equation in example 5, when I distribute and collect like terms, 2x minus 14 plus 8 and 6x minus 4x minus 2, the left side becomes 2x minus 6, and the right side becomes 2x minus 2. The sign that something weird is going on is that they're both 2x's. And so we want to know when 2x minus 6 will be equal to 2x minus 2. But the problem is when you subtract 2x from both sides to try to solve this, they both cancel out and you end up with negative 6 is negative 2 with no variable anywhere. So that's never true. And that's because this equation's never true. So this is no solution. This is what we call a contradiction. It contradicts the fact that these are actually equal. But example 6, when you distribute across 3z plus 3 minus 9, 2z minus 6 plus z. This time what happens, the left side is 3z minus 6. The right side is also 3z minus 6. And that's something that's always true. No matter what z is, it'll always be true. And this is what we call an identity. But we say that since it's true for all values of z, we say that there are infinitely many solutions. So you see here that we're describing the solution set by how many they contain or how many it has. There are none in there, and there are infinitely many in there. So you have 3 types of equations. You've got the equations where it's true for some values, conditional. If it's never true, so if it's always false, then it's said to be a contradiction. And if it's always true, then it's said to be an identity. 2.4. 2.4 is about formulas and solving formulas for a variable. So you'll most likely remember this one. It says that the formula S equals P minus 0.25P gives the sale price S of an item that originally cost P dollars, but it was reduced by 25% of the price of the jeans. Find the sale price, meaning find S, if the pair of jeans originally cost $40. The sale price is $40, P minus 0.25P. P is 40 minus 0.25 times 40. So we reduce the price of the jeans of $40 by 25% of 40, and 25% of 40 is $10. 40 minus 10 is $30. So the sale price is $30. This problem says the earnings. The problem that we just did is called a markdown. Because you see we're taking the price and lessening it or decreasing it or marking it down by something. And this one's a plus sign or a 5% markup. The earnings E equals S plus 5% of S, or 0.05 times S. And this is a formula that gives the earnings E of a business if they have sales of S dollars. Find the earnings, meaning find E, given that the sales is $12.50. So the earnings is the sales plus 5% of the sales. So we start with the sales of $12.50 and we give this a 5% markup. So 5% of $12.50 is $62.50. We add $62.50 to $12.50 and we get $1,312.50. B is the other way. It says find the weekly sales if the earnings are $735. The earnings are the sales plus 5% of the sales. The sales are unknown this time, but the earnings are $735. And so we were just doing these. If I've got two decimal spaces, multiply both sides by 100. 100 times 735 equals 100 times S plus 100 times 0.05 S. 100 times 735 is 73,500. 100s plus 100 times 0.05s is 5s. Now that the decimals are cleared, we have 105s equals 73,500. Dividing both sides by 105. We get S is equal to 73,500 divided by 105. That's 7 times 5 is 35. That gives us 700. So it was the $700 that got increased by 5% that ended up being 735. Okay, so like I said, you'll see these types of problems for the first couple of units, markups and markdowns. All right, I want to do just one more type of problem with you here, and that is examples 7 and practice 4. These are super important for the duration of this entire course. Example 7, solve 4x plus 6y equals 15 for y. And remember how I started this entire lecture off tonight when we said using both properties. We first use the addition property of equality, and second, we use the multiplication property of equality. And if I want to solve for y, I know my end answer is going to have y on the left side and everything else that doesn't have a y on the right side. So that means I don't want to have a 4x next to the 6y. So I use the addition property of equality first, and we go ahead and add negative 4x, or what we like to say, subtract 4x from both sides. Minus 4x, minus 4x. That gives us 6y equals negative 4x plus 15. They are not like terms, 15 and minus 4x, so I can't combine them. Now we use the multiplication property of equality by multiplying by 1/6 or dividing by 6 on both sides. The left side we divide by 6, and the right side we divide by 6. That gives us y equals negative 4/6x plus 15/6. Negative 4/6 is negative 2/3. 15/6, 3 goes into 15, 5, and 3 goes into 6, 2. And so now we've isolated y, and we say y is equal to negative 2/3 x plus 5/2. Doing that same thing for practice 4, we use both principles together. First step, we always use the addition property of equality first. So we want to get rid of the piece that doesn't have the y on it. If we want to solve for y, we get rid of the 6x, so we're going to subtract 6x from both sides, from the left side and from the right side. The left side is negative 3y. The right side, these are not like terms, so we just write it as negative 6x positive 18 or plus 18. Now we do the multiplication property of equality. We're going to divide by the coefficient of y, which is negative 3. Divide by negative 3.
I have a quick question.
Yes, go ahead.
How come when you're taking negative 6x from 18, it's not like 18 minus 6x?
You can write it like that, but what you'll see here in a couple weeks is that we always put the x term first. It's completely correct. For example, in the problem before it, I would be fine if you wrote the answer as y equals 5. Writing y equals 5/2 minus 2/3 x. I would be completely okay if you wrote negative 3y equals 18 minus 6x. If you've ever taken algebra before, remember this from high school, I'm trying to lead you into what we call y equals mx plus b, where the x term is first and then the number comes after that.
Okay, thank you.
Yes, you're welcome. So it's merely style. Now we divide that by negative 3, and you have to remember, like I did in the previous problem, to distribute it to both terms. Leaves me with y equals negative 6 over negative 3, which is 2, and 18 over negative 3, which is negative 6. So that certainly looks a lot better than that answer with the fractions, but sometimes you have fractions and sometimes you don't. And so y equals 2x minus 6. Okay, I'm going to go ahead and quit for tonight, but I want to take roll and I want to know who is here. Is this Abigail Spaggiati? Is that Abigail Spaggiati? Thank you, Abigail. And then the next one is it Amy Jimenez? Thank you, Amy. And the next one is Martin Castillo. Is Martin Castillo? Thank you, Martin. And then Michael yeah, you sure gave. I sure know it's you, Escobedo. Thank you, Michael. And then Nicole, I know that was Miranda. Nicole Miranda, is that your last name?
Yes.
Thank you, Nicole. And Tanya Sanabia, certainly know exactly who that is. And Taylor Prentice. Okay. If you guys have any questions, I can answer them now, or you guys are, or you're free to go. I guess you were free to go really at any time. These webinars are not mandatory. They're not worth any points. They're just good. It's a good tool for you to get to hear me teach it to. You're not bound to come to these. You don't have to come to these if you don't want to. So I'm going to go ahead and quit now. Thank you, Abigail. I'm glad you came. I'm going to go ahead and quit now. And the next one will be on Thursday. And as always, email me if you have any questions. But if you have any questions, I'll wait. I'm going to wait till the last person leaves. So have a good night, everybody.